and welcome everybody to episode 3 of my MATLAB psychtoolbox tutorial. So in the first couple episodes we went over it's like some basic syntax, like some basic function script writing, and like what everything means in MATLAB as far as like the command window and the script lines. Today we're going to go over some special expressions called loops and statements. And yeah, let's get started. So in loops, or in expressions and loops and things like that, you're going to be using a lot of these things called operators. These are just things like less than, greater than, equal to signs. And like I'm sure you've seen a lot of these before. Maybe you haven't seen like the double equal signs. But you can probably guess pretty intuitively based on seeing it next to like one of these guys, like a less than or equal to sign. This just means is equivalent to. So if this were like the expression 1 is equivalent to 1, that would evaluate to true. And then this little tilde, maybe you don't know what that means. That just means not. So this statement or this operator would mean is not equivalent to. So if it were 1 is not equivalent to 1, that would evaluate to false. The double and sign just means and, quite literally, just means that in order for the entire expression to evaluate to true, both statements must be true. So if it was like 1 is equivalent to 1 and 5 is equivalent to 5, then that would be true. The double pipe symbol is going to translate to or. So that's your or operator. And I actually didn't know how to type this for a while. So if you don't know how to do it, it's actually shift backslash. And yeah, that should give you the pipe symbol. And yeah, so that's just going to evaluate to like an or. So if it was like 1 is equivalent to 1 or 1 is equivalent to 5, then that would still evaluate to true because 1 is actually equivalent to 1. So only one of them has to be true. So the whole thing will evaluate to true. So maybe you guys already knew a lot of that. I'm sorry if I'm saying things that you guys already know, but I just wanted to go over it for anybody who might not know what some of this stuff means. So in programming, in just about every programming language out there, you're going to have things called for loops and while loops. There are other things called like do-while loops and like more complicated operations. But for now, in MATLAB especially, like really the only kind that I use like on a day-to-day basis are for and while loops. So those are the ones that we'll go over. And they're pretty similar too, but we'll go over the differences. And then the types of statements you'll see are like if statements, elseif statements, and switch statements. Elseif statements go inside if statements. This is kind of jumping ahead, but switch statements you won't see too often. Sometimes I use them to like customize certain functions. But usually you can just use an if statement with some elseif statements in there. But if this doesn't make any sense to you, I'm sorry. We'll go over what all this means in a second. Cool, so let's do some coding. So let's get out of here. Okay, so let's start off with some for loops. So in a for loop, and I'll upload this script after I make it to my YouTube video as well, so you can have it. But for loops require a variable in order to run, and that variable has to have a range of values. So you can do something like I is equal to 1 through 5, and if you remember, the colon is the through operator. So this, if we were to evaluate this, I would actually equal an array of 1 through 5, and these are separate values. So in order to actually run a for loop, you need a variable that's set to a range of values. And you can set that equal to anything. You can do like I is equal to -3 through 1, whatever, 100,000. You know, you can really set it to whatever you want. So I just use I because commonly this will be called your iterator. So let's do iteration, or iterator. I don't know, I suck at spelling. Iterator is equal to 1 through 5. So what you do is you write out your little expression, and then at the beginning you type 4. So iterator 1 through 5. Let's display. Let's use the display function, and this will just display the value into our command window. Let's display the value of the iterator, and then end it with an end statement. So what this should do is it should run through the for loop, and every time it runs down and executes here, and then here, and then back here, and then here, and then here, and every time it comes back to the top, the value of iterator is going to change. So if we were to do this manually, what we would see is it starting, and it would detect the for statement, and it would say, cool, what's the first value of iterator? So this is like literally what it would do. It would say iterator is equal to 1, and then it would say disp 1, and then it would do that, and then it would display 1. And then it would go back again, and it would say iterator is equal to 2, and then it would say disp 2. Okay, so a for loop is just a shortcut of writing this all out manually. I mean, if you were to write this all out manually, it would look disgusting. It would be like iterator equals 1, disp iterator, and then you would do this like 5 times, and you would want to kill yourself. So what you do is you write a for loop. So iterator is going to equal all these different things, and now it just displays each value of iterator. Sorry if this is going slow or fast. It's hard to accommodate everybody. But yeah, that is just the basic idea of what a for loop does. So let's look at another example where we're using an iterator that has variables. So let's set a variable equal to 5, and then let's set another variable equal to 0, and let's say for iterator. I like to use it because it reminds me of iterator. For it is equal to 1 through var. So this should say it is equal to 1 through 5. Oh, let's do 10 this time. So it is equal to 1 through 10. What I want to do is I want to take x, and I want to take the original, or I want to take the previous value of x, and I want to add 1. So if I were to do this manually, I would get it is 1 through 10. I gotta get my variables. So get my variables, and then I say it is 1 through 10. Okay, so now I have my range of values, and every time I go through, I want to take the previous value of x, and I want to add 1 to it, and that's my new value of x. So the first time it goes through this, it's going to say x is 0, and then 0 plus 1 is 1. And so if we do this manually, the first iteration value is going to be 1, and then if I evaluate my expression, now x is equal to 1. Now when I go to it equals 2, I'm going to do the same thing. And so basically this is just telling the for loop to do this expression 10 times. And so if we like clean this up and we execute this whole thing, then if you imagine we start at 0 and we do this expression 10 times, what our value of x is going to be, it's going to be 10. So we're just adding 1 to x every time we go through, and if we go through it 10 times, then it'll end up being 10. So let's look at how to use this in like a practical sense. This example is like a really common, not a really common example, but it's a good like example of like how I would use this to program a task. So let's say we have a matrix. This is just like the variable matrix, and we're going to use the magic function. The magic function just takes in a number and it creates well, this would create like a 5 by 5 matrix of like random numbers. So we just set our matrix equal to 5 by 5. I'll just show you what that looks like. So we just get like this magic matrix of 5 by 5, 5 columns, 5 rows, or yeah, 5 rows, 5 columns. And let's create a for loop that, let's pretend that this is like our trial sequence and we want to go through it, and what we want to do is we want to set all of the first column, let's say this is our trial number, we want to set our first column to 1, 2, 3, 4, and 5, because we want to say this is trial 1, trial 2, trial 3, trial 4, trial 5. And then on trial 1 it'll have like properties of each of the other columns. So these will be like the properties of trial 1, but trial 1 will actually be represented here. So this will be the trial number. So we just want to set this to 1, 2, 3, 4, 5. Now we could go through and we could like do it manually, and we could index to every single one. We could say like matrix 1, comma 1. So row 1, column 1 is equal to 1. And then, I mean, like, if we evaluate that, we're going to get, we're going to change the value in the matrix to 1. So it was previously 17, now it's 1. And then we could do that for, like, all of them. We could say matrix 2, 1 is equal to 2. Matrix 3, 1 is equal to 3. Matrix 4, 1 is equal to 4. Matrix 5, 1 is equal to 5. And then if we do this, like, obviously, and then we look at our matrix now, we'll get, like, our 1, 2, 3, 4, 5. So that's what we want to do. But we don't want to have to write out all this code. We just want to write out a for loop that'll do this automatically. So if we actually look at this block of code right here, we can actually notice that the only thing that changes from each line here is this value right here that changes with this value right here. And in our for loop, that's going to be our iteration value. So we're going to want to point to row 1, and we're going to say, yep, that's row 1. And we're going to want to point to row 2, and we're going to say, yep, that's row 2. We'll point to row 3, yep, that's row 3. So the only thing we're changing is this like one value that stays the same kind of. So in our for loop, we need to define, or well, let's just make our for loop. So we'll do for, and then our variable, which we need to declare, is equal to 1 through this, and then we'll use the size function. So we want to identify how many rows we have down in our matrix. Let's actually clear our matrix. And then get back that magic matrix. So in the magic matrix, we have we want to know how many rows there are. So we have 1, 2, 3, 4, and 5 rows. So we want to basically create a function that that tells us how many rows it has without saying like 1 through 5. Like we want a more flexible way of defining it. So what you would do is you would use the size function, and then the first input in the size function is just the matrix that you're pointing to. So in this case, we're pointing to our matrix that we defined up here, which happens to be called the matrix. And then the second input is going to be whether it's in the first dimension or in the second dimension. So in the first dimension, you're going to tell it how many rows it has. So it's the first dimension is like its tallness, basically. And if you were to say the second dimension, then it would tell you how many columns you have, so how long it is. So in this case, we want to know how many, how tall it is, basically. So if we just like evaluate that and look at that, so it tells us that we have 5 rows, which is good. So that's how many rows we want to go through. So let's clear this, and then let's also comment this out. So we want to get our magic matrix, and then we want to say IT is equal to 1 through the size of the matrix in the first dimension, which is how tall it is. And then for every row, basically, for every iteration value, we want to do this, basically. So I'm actually even just going to like copy paste this into here. And I'm going to say like, this is the thing that we want to do, except I'm just going to replace this thing that is the only thing that's changing with the iteration variable. Because every time we iterate through, this is the only thing that's changing. So when I evaluate this, and we look at matrix, it does that process for me automatically. So what's happening is that it's saying IT is this range of values, which is, you know, IT equals 1 through size matrix in the first dimension. So you get your range of values, and every time the for loop goes down and then back up, this value of IT is going to change. And the IT first value is going to be 1. So when it goes through this, it's going to point to the first row and the first column, and it's going to set that spot equal to 1, because that's the first iteration variable. And then it's going to do 2 and 3 and 4 and 5. And it literally executes like in like these lines. And if I were to say like literally what this first line does every time, what it like actually does is it resets the value of IT based on this definition here. So this is the definition of the range of values, and every time it comes back up to the top, it gives IT the next value in that range of values. And then it executes here, and it says, are we done yet? Have we reached the end of our range of values? No. Back up to the top. Okay. Change the value of IT. Come down here, execute this statement, and then have we reached the end of IT? Okay, we have. Okay, now we can exit the for loop. So that's for loops like in a nutshell. There's really cool things that you can do with for loops, like you can do for loops inside of for loops, but for now, that's pretty much all we're going to go over. So let's look at some if statements. So I'm just going to go down here. We're not running this script, so it's not a big deal. So let's just do this, and then if statements. So if statements use these operators. So that's like your equals, your less than, your greater than, your less than or equal to, greater than or equal to. So that's these guys. So the statements use a lot of those. So let's say we have 1 is equivalent to 1. Like if you were just look at this, you would say like, oh yeah, like that makes sense because 1 is equivalent to 1. So what we do is we say if 1 is equivalent to 1, then I want to display using the display function. So this is just, again, displaying to my command window. Let's clean this up. So it's just going to display to my command window. Let's display a string. So I'll use the quotes. Let's display the string statement is true. Smiley face. And then finish it with an end. So if 1 is equivalent to 1, then the statement is true. If we evaluate this, cool, it displays the command window, statement is true. So if I were to do like a 2 here, so 1 is, you can guess, not equivalent to 1. So this statement should evaluate to false. So if I evaluate it, I don't get my statement is true printed here. So what you can do is you can add an else statement. And the else statement just says, if this statement is not true, what do you want to do? What else do you want to do? So let's use this again, and let's say statement is not true. Frowny face. And if we execute this, then we get statement is not true. Okay, so it just said this is not equivalent to that. So if that's not equivalent to that, then what else do you want to do? Display this. So then what you can do with if statements is you can use like variables and stuff. So let's go down here, and let's clean this up, and let's say var1 is equal to 5, var2 is equal to 10, and let's say if var1 is less than var2, then I want, well, let's make this a little bit more complicated. Let's give it a var3, and let's say var3 is 50, and let's say if var1 times var2 is equal to var3, then I want you to set a new value to var3, and I want that value to be var3, sign. I want the new value of var3 to be the original value of var3 divided by var2. Let's wrap that in some parentheses, and then let's say I want to add all of that to var1. And then I want you to display the new value of var3. And let's end it. And so let's grab our values here, evaluate those. I should show my workspace here. I probably should have been doing that. Yeah, so now var1, 2, and 3 get set to these variables. And let's evaluate this expression. So var1 times var2 is going to equal 50, which is equivalent to var3 because var3's value is 50. So this should, programming is always theoretical, but it should display whatever this mathematical expression does. Cool, so it evaluated a 10 and it printed 10 right here. And let's double check our math. So var3 is 50, 50 divided by 10 is 5. So 5 plus 5 is var3, display var3. Cool, so we get 10. So now what we want to do, let's say that the var1 was 2. So if var1 is 2 and we reset these variables here, and we try and execute this, this is no longer true. So if that's no longer true, and we let's say we want to evaluate a new expression if that's not true. So what we do is we use an else if statement. So this goes inside of an if statement, and it takes another expression basically. It takes another line that says, okay, if this statement fails, what else do you want to evaluate? And then your last line of defense is going to be just a plain else. That's just like your if all else fails, if nothing else is true, what's your default? But in this else if, let's evaluate, let's say var1 times var2 is not equal to var3. So this should be var1 2 times 10 is not equal to var3. So this should evaluate to true because 2 times 10 is 20, which is not equal to 50. So let's just say, let's do result, or like, yeah, so what we're saying is if we get a true here, then what do we want to do? Let's say we'll create a variable called result, and we'll set that equal to var1 plus var2 plus var3. And then we'll do something kind of cool here. We'll display, let's display something that says your result is, and then the actual variable result. So the way that you do that in MATLAB is you create, in parentheses, or not in parentheses, in the brackets, you want to basically push a string and an integer together. So what you do is you create your string with quotes and you say your result is, and then you use a function called num2str, which just stands for number to string, and then in that you put your result, and so this should, and that all goes inside of your brackets. So you're basically just pushing a string, which is the string that you wrote, in with this integer that you're turning into a string. So let's get rid of this else statement. If I evaluate this expression, I should get whatever this is because this should evaluate to true. So let's do this. We'll evaluate that. So yep, you get your result is, and then 62. So 62 must be what var1 plus var2 plus var3 is, which is 50 plus 10 plus 2. So let's say that this was an equals to, or is an equivalent to expression, and we try and evaluate this, and now we don't get anything as in our display. So we want to create a default. So if this evaluates as false, if this evaluates as false, what's our default? What do we want to happen? And if all else fails, then we'll just, I don't know, just say you're doing something wrong with your life. So if all else fails, we'll just get some life advice. Cool. And there we are. So if all else fails, now we want to execute this. I think that's all I wanted to go over if statements. Yep. So now let's go down here and let's talk about some while loops. So while loops are really similar to for loops in that they like, where's my, sorry, I'm looking at my examples on my external screen. So while loops are really similar to for loops in that they sort of do this like looping iteration where they go down to the end statement and then back up and then down until some sort of condition is met or met. For loops, that condition is always the end of that range of values. In while loops, you're a little bit more flexible. So I'll show you what that means. So for while loops, instead of defining a range of values, one thing that you have to have in a while loop is you have to define some sort of like, you have to define something that's going to change. It doesn't have like this automatic changer like in for loops, how you say like it equals 1 through 5, and then the for loop changes the value for you through each loop until it hits 5, and then it says, okay, now I'm done. While loops don't know that. So while loops don't change it for you. You kind of have to define some sort of condition that's going to do the changing. So I'll show you what that means. So let's set x equal to 0. And so x is going to start at 0, and I'm going to say while x is less than 5, I want you to take x and I want you to add 1. And I want that to be the new value of x. So what's literally going to happen here is I'm going to get my x value, which is going to be 0, and then it's going to come down here, and if it's going to say if x is less than 5, then execute this statement. If it's not less than 5, then exit the loop. So if I actually start with x equals 6, then if I try and execute this while loop, nothing should happen. The value of x won't change. That's strange. I'm not gonna play with that. I don't really know what I'm doing in that. So let's just reset our value of x. And let's say x is equal to 0. And so right now, x is less than 5. So what it's going to do is it's going to come down here and it's going to evaluate this expression. So it's going to take this value of x, which is 0, and it's going to say 0 plus 1 is the new value of x. So let's evaluate this. We're just doing it manually just to show you what it does. So now x is equal to 1. And then it's going to come back up to the top, and it's going to say, is x still less than 5? And then it's going to say, yeah, it is. So execute this. Okay, x is less than 5. Okay, execute this. Okay, x is less than 5. Execute this. Okay, x is less than 5. Execute this. And then it's going to get to here, and it's going to say, is x less than 5? But x is equal to 5, so it's going to say nope. So it's going to exit the while loop, and it's going to come down here to wherever's down here. So every time I run this, x should always end up being the value of 5. So if I clear this, and I get my x variable, and I execute this, x is going to equal 5. So this is kind of cool. This is like a different way of like getting a changing variable inside of a loop, but with like very different properties. So like with while loops, you can be really precise with like how you want to control it. So I have a really cool example here that shows you just like how powerful while loops can be. So let's go down here and let's I'll write out this example. So this is also like a really practical example of how I would use while loops in like my programming. So let's define a duration of time. So I'm going to define a variable called duration, and I'm going to say equal to 3. And in my head, I'm thinking, okay, duration is going to equal 3 seconds. So just sort of roll with me in this metaphor for a second. And so I'm going to say my start time, I'm going to set my start time equal to getSex which getSex is just a built-in function that gets an estimated seconds, like current seconds in the day. So if you actually do that, it'll give you a number that looks like this. It's going to look really weird because it's actually collecting more information than just like, well, it's collecting like the amount of seconds, but like it's a lot of seconds. But what you can do is you can set a time. So if I set my start time equal to whatever now is, and then I sort of go into the future and I say like, okay, 1 second from now, let's say start time is 0. Like if we just zero it out and like neutralize it. So if the start time is 0 and 1 second from now is 1, because when you do getSex minus your original start time, you do like 1 second from now minus now. That difference is going to be 1 second. So that's sort of like how you can measure time using getSex. So I'll show you like how or like what that means. So let's set another variable equal to 0 for our while loop. And in our while loop, we'll say while getSex. So every time it goes through this while loop, it's going to get this seconds estimate. And it's going to say getSex minus start time. And if that is less than our duration, if this estimate, like this expression, if that's less than our duration, then execute some sort of statement. And I want my statement to say x is equal to x plus 1. So, and then we'll just end it. So like, this is literally saying, if our start time is 0, and we do the amount of time that has passed minus 0, so let's say it's like 1 second from the start time, you do like 1 minus 0, because it's been 1 second. If that's less than our duration, if it's less than 3 seconds, then I want you to execute this expression. And remember, all this is doing is it's taking the value of x, or the previous value of x, and just adding 1. So every time this while loop comes around and like goes down, it's going to evaluate this expression for 3 seconds basically, because we defined our duration as 3. So when I actually execute this, the information that we're going to get is how many times can a while loop go through itself in a matter of 3 seconds. And if we execute that, what happened? Oh, I said is less than, so it's gonna start off as less than. So I want to say greater than. So if getSex minus start time is greater than our duration, so as soon as it's greater than the duration, oh wait, no, that should have worked. Hold on. So while getSex minus our start time is less than or equal to our duration, I want you to run that. That is strange. getSex minus start time. Oh, I'm evaluating getSex earlier. So what was happening was I was evaluating getSex, and then I was waiting a few seconds, and then I was doing the while loop minus that start time, so I was already past the duration time. So all I need to do is execute this all at once. So when I evaluate this, it'll wait down here, and then it'll come out. And then when we look at our value of x, we see that this expression got evaluated through our while loop close to 1,000,000 times in 3 seconds. So x kept adding 1 to itself until it was less than a duration. So that's just an example of how powerful while loops are. I mean, this thing was just plowing through while we were sitting there, almost a million iterations. I think that's really cool. I noticed this when I was making this example, and I thought it was a really cool thing to share. So another thing that we can do is we can add if statements to these while loops. So what I want to do here, and I'll introduce another cool thing called break. Break is just going to break us out of the while loop if some sort of condition is met. So let's say if x is greater than or equal to 500,000, then I want you to break. So this is every time this loops down, it's going to do its +1, and then it's going to evaluate this if statement. And it's going to say if x is greater than 500,000, then break out of this while loop, meaning like this while loop, like break completely out of it and come down here. So if I do this, then x should end up being the value of 500,000, because as soon as it is, because it's just going by ones, as soon as it is 500,000, it'll stop and it'll break out of the while loop. So if I clear this up and I run all of this together, and it breaks out, my value of x is 500,000, because as soon as it reaches this condition, it breaks out of the while loop. I just thought that was a pretty cool example, just to like see how powerful these things are. I mean, that can do a lot. You can do a lot with that, and I mean, you could set this to whatever you want. You could set it to like 3, 6, 7, 8, 9, I don't know, and then just like do this, and x will always evaluate to like whatever this is. And that one did it really fast, because apparently, I mean, this is a small amount of iterations for a computer, so x is, it'll evaluate to that. Cool, so that's all I wanted to go over for while loops. And we'll just go over switch statements briefly. You really won't use these a whole lot, because they're really similar to if statements and elseif statements, which we did up here. So like a switch statement is going to be really similar to this. So you're going to want to say like, if this thing is true, do this. If this one is true, do this. If this is true, do this. Like, it's just sort of a different format of doing it, and sometimes it can be a little neater. But I will go over it anyway. I think they're pretty cool. I like using them sometimes, like, because I think it looks cool, and they're like, it's always fun to try and optimize things in weird ways. So for a switch statement, you need a variable. So we'll set like a equals to 5, and then we'll say switch, and then our switch is going to depend on the variable a. So that's how switch statements work. They kind of have like these dependencies, and so our a is going to be our dependency. So then it has these things called cases. So in the case that a, so what this is going to say is like, in the case that a is equal to 5, I want to display the string a is equal to 5. In the case that a is equal to 4, then I want to display a is equal to 4. And then that's all you have to do. So this looks like a tiny bit neater in some cases. It's like, kind of just depends on what you're doing, but it's essentially doing the same thing as if you were to write like a equals 5, like if a is equal to 5, this, whatever, else, if So it's like literally, it's pretty much the same as doing that. Cases are just like, or switch statements are just kind of a different way of doing it. So if we evaluate this, so our a is equal to 5, so in this expression, the dependency is on the variable a, and then in the case that a is 5, then you want to do this, so our switch statement should tell us a is equal to 5, and then obviously if we change this to 4, then our switch statement is, our switch statement is going to tell us that we gotta reevaluate our variable. Then a is equal to 4 down here. Yeah, so switch statements, they're not like super used. I wouldn't worry about them too much, but that's just like a basic introduction to them. But yeah, that's all I really wanted to cover in this video. If you guys have any questions, obviously feel free to ask me in the comments. I really like doing these videos, so let me know if there's like a certain thing that you want me to go over, or like show you how to do. I can't promise you that I'll know how to do it, but I'll definitely like research it and figure it out and try and show you a quick tutorial on how to do it. But yeah, that's it for this video. Cool. Bye.